Hi everyone, welcome to my channel Code with Ease by Varsha. Today we will talk about how to make effective notes when you are learning system design. So what happens is when we read about system design, usually we read about certain case studies or scenarios of how to design such and such system. So most of us just usually give it like a casual read, just read the blog, the article, and we just keep it away. And eventually we forget later. And we know that most of these studies are quite verbose in nature. So the reason I forget is because there are two reasons. Maybe we are not preparing for an interview, so we do not feel like saving that article or maybe making notes out of it, so we just park it for later use. And even if you are preparing for an interview, most of us do not know how to take effective notes. So I just want to say, whether you are preparing for an interview or you are not preparing for an interview, learning about high level system design, the case studies, is not just limited to cracking some interview. It is about getting an in-depth understanding of how a system works, how a certain system works. So usually my way of making notes is I go through different blogs like you guys do. I also refer to this book and I make notes out of it and publish articles, like I write on Medium also. So I'm going to refer to one such article which I have written, which is in the way that how I make notes when I read about system design. So using that article as a source, I'm going to show you today how to make effective notes when you are learning about system design. So with that, let's start. So this is the article which I had written on Medium on the system design of YouTube. How does it stream millions of videos daily? Now using this as a source, I'm going to show you how while writing this article, I made notes of this entire case study. So whenever you sit for making notes, always try to remember you have to try to divide it in certain blocks. For example, I've divided this into 6 modules. Number one, the functional and the non-functional requirements. Like many of you already know, what is the system doing? That is the functional requirements. Non-functional requirements meaning you have to understand that what is going to be, let's say, the scalability of the application, latency, reliability, all of those things. Now, these two things should be very clear about when you're starting to sit with the system design notes. Then, second thing is about the building blocks. When I say building blocks, what do I mean? Like the load balancer or the CDN or the databases, what you are going to use while you're trying to build the system. Now, when you're sitting with the system for the first time, it may not be very clear to you what building blocks you're going to use. So you can skip this part, but you can start with at least the back of the envelope calculations or the resource estimation. How many servers we are going to use? What is the storage we are going to use? We'll talk about this with example more on this. Then once you're clear with this, then you at least have an idea of what can be your building blocks. Once this 1, 2, 3 is done, then you can go to your system APIs and the database design. Next, you can now do a deep dive or a breakdown of the building blocks which you have mentioned. Those components, what are the components, how the diagram is going to be, like the flow diagram, which component is interacting with which one, how the diagram is going to be. And in this case, specifically about the video uploading and the streaming flow, for example, in case of YouTube. And finally, your non-functional requirements, meaning whether you have been able to meet, let's say, the latency requirements, the scalability requirements, and all of that. So on a very brief overview level, when you sit down to make notes for system design, this is how broadly you can organize your notes. This is the thing, these are the things which you are going to ensure that you have it in your notes. Whether you are taking physical notes or digital notes, it doesn't matter. Now let's say for this case, in case of YouTube, what is my functionality of the system? I want to upload the videos. When I upload the videos, the user should be able to stream the videos, search videos, then they should be able to interact, like, dislike, put comment, share, subscribe to the channel, all of that. So we are talking specifically about the video. So add comments, then users may want to view the thumbnail. So these are some of the functionality aspects. So you have to just jot it down. What is the functional requirement of the system? Once you're clear with this, next is the non-functional requirement, like how it should behave, not what it should do. So in case of YouTube, we have high availability being one of the main lookout for us, that it should be always available and accessible. Scalability, there's a lot of users, content creators are also growing, and the number of user base is also growing. So scalability, performance, reliability. So again, this can vary from where you are sourcing your study material, whether you're reading a blog or a book or studying from YouTube video, the requirements can slightly vary. So whatever you understood and whatever makes sense to you, you make a note of those points under the non-functional requirements. The next point is the building blocks. So now in this case, we have identified that I am going to be using, of course, a database because I need to, from the function requirements, I understood I have to store the data. So of course, I would need the databases to store the metadata of all of these videos, thumbnails, comments. I need a blob storage for storing my videos because blob storage is used for storing whenever you have large quantity of unstructured data like images and videos. CDN I need to be streaming the content to users globally. So I would need a CDN. Load balancers, servers, encoder transcoders are specifically to this use case because I want to compress the videos. I don't want to store 600 MB of video. I just want to compress it and store to save on the storage space. And transcoder is needed because I want to render it in different resolutions. You just pause and read about these sections also what I mentioned. So this is the very high level overview what components I want to use. Now you may be able to figure it out at the beginning or you may not be. It depends. So you can keep this area blank also. Then coming to the most important part, the estimation, or we call it back of the envelope calculation. I have also done a very quick 5-minute video on my channel on this example on how to do. So let me reiterate, let me talk about it. So whenever you do back of the envelope calculation, this chart which I have mentioned, this should be very clear. You should be able to visualize this chart always in your mind. What are these notations meaning? Okay. The next thing, for example, I've given an example on how I'm actually doing the computation. For example, the total number of YouTube users is 2 billion. So when I say billion, again, I'm going to keep into mind that 2 into 10 to the power 9 I'm going to do. Into the details of the calculation because I am going to anyway link the article in the description so you guys can read this. But the point which I'm trying to make is it is broadly divided into 3 things. One is a storage estimation. Here, what is my outcome of this? What am I trying to calculate? That if I have a 10-minute average video being stored, then how much, what is the total amount of storage at the end of the year I would need to keep for myself? So based on the calculations which we have done, that a 1-minute video will require 5 MB of storage. Hence, if there are 500 hours of video uploaded every single minute, I need 150 GB just for storing videos of 1 minute, which means in a day, I would need 216 terabytes. And then for a year, 79 petabytes. So this is, so you see, we started from 1 minute of content and then we moved to find out 1 year of content, like 1 year of storage, right? So this is how your estimation should be done, because if you don't do this, the rest of the steps which you are going to take, you will not be able to understand what kind of databases you should choose and all of that. Next is, we talked about this transcoding it into different resolutions. You see that, right? So if I have to store it in 5 different formats, actually I need more storage, right? So basically 79 petabyte is going to be maybe for one format, this entire thing, because I have 5 formats. I would need to multiply the storage with 5 times. Next is the bandwidth estimation. Now, what does it mean? That how much your system will be able to handle the load when I'm trying to upload it or download it, like the upload and the download speed, right? So when I'm as a creator, there are multiple creators trying to upload videos on the YouTube. So how the server will be able to handle per second, how much data of like content or videos worth of hours it is going to handle. And on the other hand, when I say download, I'm saying in the streaming space, how much, because there are multiple users concurrently who are tuned into YouTube and watching multiple videos concurrently, then how the system is going to handle this streaming bandwidth. So that is why this estimation is very crucial. So for example, the upload to view ratio, let's say, is 1:100. We can take any assumption and move on. So which means for one video uploaded, there is 100 views per second, let's say. Now when we did the storage estimation, we assumed that the storage I'm always going to be doing on the compressed format. So my 600 MB's video became 50 MB because I compressed and stored it. I'm not storing the original video. But when I am doing the streaming, when I'm doing the uploading of a video, when I'm originally just uploading one video, I'm uploading the entire original video. Later on the server side, it is getting compressed. But when I'm uploading it, then it is my raw video of 600 MB. So my system, the server, should be able to handle 600 MB of video from per user, let's say per second, right? There are so many users coming in. So then how am I going to calculate the bandwidth? This is the formula of bandwidth: traffic into average response size, which means how much content you are transferring and what is the size of the content that you are transferring in let's say per minute. So in case of this example, let's say I have a 600 MB of video and the video is 10 minutes long, which means what is the length, the MB of 1 minute before compression is 60 MB. So in every 1 minute I'm uploading 60 MB of videos as just one user. Okay, now what is my upload bandwidth? So I have in totality across the world 500 hours of content is getting uploaded every hour. Okay, and in every hour, okay, see 500 hours of content getting uploaded every hour. This much calculation is clear. Now in the MB, the storage capacity, I mean the size of the video per minute is 60 MB. 60 MB into this multiplied by this, and we are converting the bits per byte because we want this in BPS, bits per minute. Because we want it in bits per minute, that is why we have to multiply into 8 to get the bits per second. Sorry, we have to get it in bits per second. This is all the conversations, all the conversions are done in the terms of second. That is why we have multiplied into 60, which gives us 14 terabyte per second. Like, I think the notation should be terabits per second. It is like TBPS. That is a typo. It should not be B. It should be TBPS because that is why we have multiplied it by 8. Anyway, which means I'm saying the system has a bandwidth capacity of 14 terabits per second. This is the right notation, TBPS. To handle the process of uploading videos to the platform, it needs 14 terabits per second. It has to handle that much capacity. Only then it will be able to accommodate the transfer of data from users who are uploading the videos to the server where they're stored and processed and compressed and all of that. So that is the point which I am trying to say. This bandwidth is going to make the YouTube servers capable of handling 14 terabits per second of content. That is why this estimation is important. The next point is about streaming the videos, which means you're talking about the download. Now, as a content creator, you have uploaded the video, but as users, you are going to stream the videos. The biggest difference between this is when you're streaming the video, you're actually going to show to the users or fetch from the compressed videos which you already have. So now in this case, after compression, my 60 MB video which was being uploaded, which was of 1 minute video, has now become 5 MB. I have compressed the video. So now I have 5 MB of video. So now see the calculation. Again, 500 hours of content, 60 hours per minute. Now 60 MB became 5 MB. And here we are multiplying it by 100 because we have the view to upload ratio. You remember? One video can have 100 views. So I have to take that into account. So for one video, I had 60 MB per minute storage multiplied by all of that, which gave me 14 TBPS above. Now for that 14 TBPS, now I have to ensure the view ratio is also taken care of. So for all those videos, I have to multiply it by 100. So that is why I am now getting total 2 TBPS. 2 TBP because remember I have compressed the size. So my bandwidth of uploading was 14 TBPS and of download my bandwidth is 2 TBPS. The reason I have elaborated on this calculation is when you're making notes, you have to understand also with example how you are going to write the back of the envelope calculation for this. So again, if you want to understand the calculation above, you can pause the video and just read about this. So streaming bandwidth of 2 TBPS, which means that system can handle the simultaneous transfer of data at the rate of 2 terabits per second, which it was in case of uploading 14 terabits per second. So this will allow the platform to efficiently deliver the video content without any buffering. This is the main point why we are trying to do this estimation before. So that if there are multiple users who are trying to stream the videos concurrently, the total data transfer rate, like bandwidth is nothing but the data transfer rate. So that whatever is needed will not exceed this much. We can of course have a buffer, but this is what is the broader estimation that we have. So after doing the bandwidth estimation and the storage estimation, the next point is about the server estimation. Now, to do the server estimation, how we are doing it, we are doing assumption that let's say a server can handle 5,000 requests per second. Usually ranges between 5,000 to 8,000. And if you have these many daily active users, actually this is the total number of users. The daily active users were lesser, but we will do it in the sense that we will take all the users into account. Okay, what if all the total user base is also active on a certain day? So The number of servers, you can actually take the daily active users, or it is better to take the entire user base so that you can have the maximum allocation done, divided by how many requests your server can handle. So this is the calculation that we do, that we would need these many number of servers to handle 2 billion users per day, right? So this is the server estimation that you have to do. So this will wrap up your back of the envelope calculation part. The next part is about the system APIs and the database design. Now, as I have already discussed, the functional, non-functional requirements are done. You made a note of the calculations. You also maybe made a note of the building blocks. Now, system APIs, how will you decide what are the APIs? Very simple. You have to relate to the functional requirements. So we had a functionality of uploads. We would need upload videos, stream videos, like that. So different functionalities will correspond to each different API. And this is how you're going to write the specs also, that for upload video, what are the parameters that you're going to take? For stream video, what are the different parameters, like that. So you have to make a note of these APIs because this is also important. After doing this, you will do the database design. Again, this will correlate. So your functional requirements, your APIs, and your DB tables. All these three should be aligned to one another. Otherwise, you will not be able to make the correct system. So in case of, let's say, in case of user table, the very obvious choices that we have. Then in the video table, what are the most important details? Now you may miss out on a field, a column or two, that is fine. But what are the mandatory ones? Like a video is uploaded by a user, so that user ID has to be there. A video should have a title, a description, when it was uploaded. Okay, what is the duration of the video? All of those details are the mandatory fields that you would need. Comment table, channel table, like that. So once you're done with this, you can say that you are now at a point that you have ready. Your notes are ready for you to refer anytime. So now you are in this point. So when you reach till here, you can say that let 50 to 60% of your notes is ready. It's done. So now that we have covered the APIs and the DB design, the next part is the now that we have covered the APIs and the DB design, the next part, the most important part, which is the integration part. Now that you have identified the functional requirements, followed by the building blocks to design the APIs, everything is ready. But the building blocks that we had put in the first place, now we have to put that in the flow. Now we have to integrate them. And we have to show how the components are going to interact with each other to build the system that we eventually want to build. So over here, although I have given the steps like one by one, basically I'm just talking of the workflow, the flow diagram. So the best thing is, instead of writing too much theory on this, you should be, when you're making the notes, you should be adding more diagrams like this and this, where you're trying to depict the flow by putting all the components next to each other, connecting them with arrows, and show how the interaction, the data flow, and everything is happening. So this is the most crucial aspect, the climax of the system design notes that you're making. This workflow design, there are many different tools you can use. If you're using it digitally, or best is to use pen and paper and to draw this and have multiple diagrams depicting the flow. Like for example, here, this one is the entire flow. But to go a little bit deeper, we have depicted the video uploading flow over here, right? And then secondly, the video streaming flow over here. You can also break down the separate modules and draw the diagrams for that. So once you have made the diagrams like this, then you can just write this final steps like point one, point two, what is happening, just to give more context about what the diagram is. That is it. Very simple. That is the only thing which you need to do to depict the flow diagram. And finally, the sixth module, where we will see if the non-functional requirements which we had laid, which were written before, are those aligning with the design that we have come up with. For example, we talked about availability. We talked about low latency. Now we have introduced CDN in the picture. Why? Because we want smooth playback experience. We don't want the buffering to happen, right? So that is the reason we have introduced it, and that is going to guarantee the latency of the smooth streaming, low latency of the smooth streaming. Next is the scalability requirement, then the availability, where we are introducing two types of load balancer, local and global. So we just have to justify whatever design we made, are those aligning with the non-functional requirements or not, and you just make a point of those. If not, then maybe you have to revisit the some other blog, or maybe refer to some other videos in order to actually see that your design is correct. Because it is not like whatever case study you're reading from wherever, which resource, is completely accurate. Many different people have different interpretations. So you have to make sure. Now this particular article also, which I'm showing, it is not sourced from just one single place. It is sourced from multiple different places. So I had to sit and curate and have the accurate information, tweak the diagram from time to time. So that is the reason I'm saying, in this way, if you make the notes, then it is going to serve you like lifetime. You don't have to worry about revising any kind of system before, let's say, you go for an interview, or maybe to understand any kind of system just in general for your everyday work. So on that note, we are wrapping the video for today. Thank you so much for watching. And I'm going to link this article also in the description. You guys can check it out. So for those of you who have not subscribed to the channel, please subscribe to it. Spread this video among your friends and peers, whoever might find it useful. And let me know in the comments below if you have any suggestions or any questions. Thank you so much for watching.